These are glass beads. Each one is about a millimeter across. They formed when rock was vaporized, thrown clear of the atmosphere, and cooled on the way back down. They were found in North Dakota, 3,000 kilometers from the place where that rock was vaporized. And they were found inside the gills of a fish, which means the fish was still in the water and still breathing while they were coming down. Everybody knows what happened here. 66 million years ago, an object about 10 kilometers across hit the Yucatan Peninsula, and about 3/4 of the species on this planet died. The question nobody asks is why it worked. Because an object that size hits the Earth roughly once every 50 to 100 million years. And most of the time, nothing remotely like this follows. This is before us, the history of the world before anyone was here to see it. The date is 66 million years ago, and for the next 90 seconds, we are going to move in real time. And hold on to that fish. We are going to come back to it, because it turns out to know something that nobody thought could be known at all. Second zero, the object enters the atmosphere at around 20 kilometers per second. It is large enough that the air does not slow it in any measurable way. If you were standing on that coastline, there would be no warning of any kind. It crosses the last 100 kilometers of sky in about 5 seconds. It strikes a shallow tropical sea at an angle somewhere between 45 and 60 degrees. Second one, the seafloor is punched downward to a depth of around 30 kilometers. At these pressures, rock does not shatter, it flows. The floor of the hole rebounds upward, throwing a column of molten and vaporized material back out through the gap the object tore in the atmosphere. Some of that material leaves the atmosphere completely. Minute 2. A pressure wave moves outward across the sea and the land beyond it. Within about 1,000 kilometers, wind arrives at speeds that nothing on the surface has ever had to survive. Hour 1. The material that left the atmosphere begins to come back. It re-enters, and re-entry turns the upper air into a heat source pointed downward at the whole hemisphere. And 3,000 kilometers north, in a river system in what is now North Dakota, the water starts to move. Now, before we go any further, one question. You already know what killed them. An asteroid hit the Earth and the dinosaurs died. It is one of the few things about deep time that everybody knows and that nobody has ever had reason to doubt. Put it in the comments now so you can see where you started. I will come back to it. The crater first. The final structure is about 200 kilometers across. It is buried now under the northern edge of the Yucatan and the sea beside it, and it was not identified until the 1990s. The angle matters more than you would expect. Modeling published in 2020 puts the impact at somewhere between 45 and 60 degrees from horizontal. That happens to be the worst available case. A steeper strike buries more of the energy in the ground. A shallower one deflects more of it away. That middle range is the one that throws the most material up into the atmosphere and keeps it there. So before anything else, the geometry was unhelpful. And then there is the fish. 3,000 kilometers north of the crater, a river system drained into an inland sea. The site is called Tanis, and what it preserves is not an event across millennia. It is a few hours. Seismic waves from the impact traveled through the crust far faster than any wave could travel through water. When they arrived, the water in that river system began to slosh, a standing wave called a seiche, and it drove a surge of sediment across the floodplain, burying what was living there. And in the gills of fish buried by that surge, there are impact spherules. Now I want to be straightforward about this site because it is one of the most quoted and least verified places in paleontology. The surge deposit and the fish are described in a peer-reviewed paper. That part is solid. The more spectacular claims from Tanis, a dinosaur leg with skin on it, a pterosaur embryo, a turtle impaled by a branch, are not fully described in the peer-reviewed literature. The site is on private land with controlled access. And in 2023, an investigation by the University of Manchester found that the researcher who leads it had committed research misconduct in the form of poor research practice. So this episode uses the fish and the surge and nothing else from Tanis. The fish is enough. So there it is, the first answer, and it is the one everybody has. An object 10 kilometers across hit the Earth, and the impact was so large that it ended an era. But there is a problem with that, and it is a problem of scale. An impact of this size is, in planetary terms, a regional catastrophe. The blast, the heat pulse, the tsunami, those are enormous, and they are also local. Within a few thousand kilometers, nothing survives. Beyond that, the direct physical effects fall away fast. That is not what a mass extinction looks like. A mass extinction kills things on the other side of the world that never felt a tremor. So the impact by itself does not explain the outcome. Something has to carry the damage globally and then stay there for years. And the thing that did that was not the asteroid. It was the rock the asteroid landed on. Chicxulub did not hit granite. It did not hit deep ocean floor. It hit a shallow tropical carbonate platform, a seabed built out of limestone, layered with evaporite deposits rich in sulfur with hydrocarbons buried underneath. When that was vaporized, it did not just throw rock into the sky. It threw chemistry. In 2017, Kunio Kaiho and Naga Oshima at Tohoku University asked a question nobody had put in quite that form. They took the mechanism, target rock vaporized, aerosols into the stratosphere, sustained cooling, and ran it against a reconstruction of what the Earth's surface was actually made of, 66 million years ago. Then they asked how much of that surface would have produced this outcome. Their answer was about 13%. Most of the planet, including almost all of the ocean floor, would have given a far milder result. Enough to be a catastrophe, not enough to end an era. So the dinosaurs were not killed by an asteroid. They were killed by where it landed. Which raises the next question. How does chemistry in the sky over Mexico kill something 8,000 kilometers away? The answer is that it stops the light. Anything fine enough stays airborne. Particles below about 10 micrometers do not settle out under gravity in any useful time. They reach the stratosphere, above the weather, where there is no rain to wash them down. And once enough of that is up there, the amount of sunlight reaching the ground falls, not by a little, by enough that photosynthesis stops being possible. Everything downstream of that follows automatically. Plants stop. The animals that eat plants stop. The animals that eat those animals stop. The structure comes apart from the bottom, which is the only direction that takes everything with it. And it is worth being specific about what that looks like on the ground, because it is not dramatic. There is no fire and no flood. There is simply a forest in which month after month nothing new grows. For most of the last 40 years, the argument has been about which particles. Two candidates dominated. Soot from wildfires ignited when the ejected material came back down and turned the upper air into a heat source. And sulfate aerosols from the sulfur-bearing rock at the impact site. One published estimate puts the sulfur release at around 325 gigatons. And the researchers who produced that figure described it as conservative. Both produce cooling. Both have been modeled extensively. Both are in every account of this event you have ever read. So that is the second answer. Soot and sulfur filled the stratosphere, the sun went out, and the food chain collapsed from the bottom. It is the standard explanation, and it has been for decades. In 2023, it was substantially rewritten. The rewrite came from doing something completely unglamorous. Somebody measured the grain size. A team led by Kemberg-Senel took the boundary layer itself, an unusually thick and well-preserved section of it in North Dakota, and ran laser particle size analysis on the silicate dust inside it. Not modeling, measurement. What came out was a distribution that nobody had put into the models. The dust was dominated by particles between about 0.8 and 8 micrometers across. That is finer than a grain of pollen, and it is almost exactly the size range that stays in the stratosphere longest. When they fed the measured distribution into a paleoclimate model, the numbers moved considerably. An atmospheric lifetime for the dust of around 15 years, a fall in global average surface temperature of as much as 15 degrees Celsius, and a shutdown of photosynthesis lasting almost 2 years. Soot and sulfur still contribute, but in this reconstruction they are not the main driver. The main driver is dust, pulverized rock ground fine by the impact itself. The thing that switched off the sun for 2 years was not smoke, it was the seabed. And a further paper published in 2025 went in the same direction from the other side. It re-examined the sulfur contribution and concluded that it was smaller than had been assumed. This is an area that is still moving, and I do not want to give the impression that it is settled. But the direction of travel is clear enough. It is away from fire and towards dust. Which leaves a question I have been avoiding. If photosynthesis stopped for the better part of 2 years across the entire planet, then why is anything alive? Because something did survive, not much, but some. And the pattern of what came through is the most informative thing about this entire event. More informative than the crater, more informative than the dust. Start with what did not survive. Every non-avian dinosaur, every pterosaur, the ammonites, most of the large marine reptiles, and in the oceans, a catastrophic loss among the calcifying plankton at the base of the entire marine food web. Now what did? Crocodilians, turtles, lizards and snakes, amphibians, small mammals, and one group of dinosaurs. At first glance, that list looks arbitrary. It is not. Almost everything on it shares one of a small number of properties. It was small, or it lived in fresh water, or it burrowed, or it could go a long time without eating, or it could eat something that was not a living plant. None of those is a strength. Every one of them is a way of not needing the thing that had stopped. That last one is the important one. A forest that has stopped photosynthesizing is still full of material. Dead wood, leaf litter, seeds, insects working through the rot. Detritus food chains do not run on this year's sunlight. They run on sunlight from previous years stored. So the animals that came through were, overwhelmingly, the ones plugged into a food chain that had a delay in it. And the clearest case is the birds. In 2018, Daniel Field and colleagues showed that tree-dwelling birds did not make it. The forests collapsed, and the lineages that lived in them went down with the forests. The ancestors of modern tree-dwelling birds only moved back into trees once the forests had recovered. What survived on the ground were beaked birds. And a beak, unlike a mouthful of teeth, can process seeds. A seed is stored sunlight that keeps. Which brings us back to that fish. When Melanie During and her colleagues examined the fish from Tanis, they were not looking at the gills. They were looking at the bones. Fish bone grows in cycles. A layer thickens through the growing season and thins again as the year turns, in the same way that a tree lays down rings. In a fish that died on one specific day, the outermost layer records where in the year that day fell. They sectioned the fin spines. They ran the growth histology and the stable isotopes together. The outermost layer was just beginning to thicken. The impact happened in spring. That sounds like trivia. It is not. In the northern hemisphere, spring is when animals come out. It is when they are breeding, feeding, growing, and least able to shut anything down. Eggs are in nests, young are dependent. At the same moment in the southern hemisphere, it was autumn, the season when animals are entering dormancy, storing fat, going underground. The authors of that paper put it directly. They proposed that the timing of the impact, boreal spring, austral autumn, was a major influence on which groups survived and which did not. The object hit half a planet at its most exposed and the other half at its most prepared. Nothing about that was aimed. It is simply where the Earth happened to be in its orbit on the morning it was hit. So what actually happened here? 4 things had to line up, and not one of them was inevitable. An object of the right size, large enough to matter, and they arrive perhaps once in 50 to 100 million years, at the right angle. Between 45 and 60 degrees, the range that lofts the most material and keeps it up, onto the right rock. About 13% of the surface, made of exactly the wrong chemistry, at the right moment in the year. Change any one of those, and the animal outside your window is not the last kind of dinosaur left, because there would be a great many more of them. This was not a verdict on the dinosaurs. It was a coincidence, 4 layers deep. And that is the part I find hardest to hold. Dinosaurs had held this planet for 165 million years. There was nothing wrong with them. There is an active argument about whether they were already declining. One study finds a downturn beginning around 76 million years ago. Another argues that the apparent decline is an artifact of where the rocks that preserve fossils happen to be, rather than a fact about the animals. That argument is not resolved, but none of it was going to end them. What ended them was a rock hitting another rock in the wrong month, and in the dark that followed, something small was eating seeds. That is the sentence I keep coming back to. The dinosaurs were not killed by an asteroid, they were killed by what the asteroid landed on. The object was ordinary. This planet catches things like it on a schedule. What was not ordinary was a shallow tropical seabed, loaded with sulfur and buried carbon, sitting in exactly the wrong place on exactly the wrong morning. If this is the kind of thing you want more of, slow, careful, and honest about what we do not know, the like button genuinely helps this channel find people like you. And the answer you wrote down at the start, an asteroid killed them. An asteroid did arrive. That part is right. It just was not the asteroid that did the killing. It was a shallow seabed in the wrong place and a morning in spring. Because the survivors are still down there, small, in the dark, eating seeds and insects and whatever the forest floor still had left in it. In a few million years, they will be the largest animals on land and in the sea, and almost everywhere in between. One of them is eventually going to end up watching this. That is where we go next.